This is a how-to video on gram conversion problems. These are just like the other conversion problems we did at the beginning of the year, but with these we're looking at the elements and converting between grams, moles, and number of particles per substance that we have. So we're going to use a proportion like we have before. And this proportion centers around what's called the molar mass. So we have a molar mass, and this is the mass of 1 mole of your pure substance. So it could be an element or a compound. For the element, so to find, for an element, look on periodic table. For a compound, add the mass of each atom. So to start off, we can convert between grams and moles. Our first example would be 5 grams of CO2. CO2 has a molar mass of 44.009 grams. This is the mass of 1 carbon plus the mass of 2 oxygens added together to give us 44.009. Then we set up a proportion. 5 grams of CO2 over question mark number of moles equals 44.009 grams over 1 mole. We do our cross multiplying and we have x moles times 44.009 grams equals 5 grams and 1 mole. If we divide both sides by the 44.009 grams, x equals 0.114 moles. Okay, so we use this molar mass, which is the mass of 1 mole, to set up our proportion. We can do it the opposite way if we look at, say, 5 moles of CO2 and we're interested in how much that would weigh. We could put in the same proportion. This time we're looking for grams equals 1 mole over 44.009 grams. Again, we want to match up our units, so I put moles on top over here. I need to put moles on top over here. If we look for that, grams equals 220.045 grams. Now the trickier part is when we're looking at going between grams and number of particles, or dealing with the number of particles. When number of particles is taken into place, we need to use Avogadro's number. So if we're going grams to number of particles, or the other way, number of particles to grams, we will use 6.02 times 10 to the 23rd atoms, or Avogadro's number. To do this, going from moles to number of particles, you would set up one proportion just like you did here, because this is the number of particles in a mole. When you're going grams to number of particles or number of particles to grams, you have to do the middle step in converting either to moles. So for example, we'll go back to our 5 grams of CO2, and this time we want to know how many particles. First we have to do the 5 grams of CO2 over our moles and convert to moles. After we get this answer, which we know from above is the 0.114, we need to do the second step of converting the moles to the number of particles. So we would put 0.0114 moles over question mark particles equals 1 mole over 6.02 times 10 to the 23rd. If you do your cross multiplying and dividing, our x equals 6.84 times 10 to the 23rd particles. If we were going from particles to grams, and say we started out with 6.0 times 10 to the 56 particles, and we were curious about how much mass that would be, we first need to set up our proportion. And we have 6.0, our proportion to moles. Do our cross multiplying there, and then we would set that up. This answer would go here over question mark grams, and we would use 1 mole over the molar mass. So in this case, if we still were using the CO2, the molar mass would be 44.009 grams. So they still have that double step there.